Yesterday we looked at the sine law and we figured out how that works, but today what we're going to do is look at a special case that sometimes happens with the sine law. We call it the ambiguous case. And ambiguous basically means you're not sure which it is. So with certain situations we can actually get two different triangles that have the same measurements. So if you look at this title page one, we've got a 33-degree angle for C. We've got length 10 and we have length 6. But we could actually draw the triangle in two different ways. We could have the 6 drawn like that, so it looks like a normal triangle. Or we could actually draw the 6 sort of coming backwards, and it would look like that. So you can see the 33, 10, and 6 stay the same. The only thing that would change would be angle B would be different, and angle A would be definitely different depending on which of the two scenarios you got. So this actually causes problems when we're doing some of these triangles, and you got to be really careful that you may or may not be dealing with the ambiguous case. And it's actually been documented in history that sometimes people trying to locate certain things have actually went to the wrong spot because of the ambiguous case. So what we want to do is, when you get a word problem, obviously if the triangle is given to you, it's pretty safe to just solve it. But if it's given to you as a word problem, we get two possible scenarios sometimes. So if we look at this one, we have angle A being 45. So let's try to draw that out. So we've got 45 for angle A. It says side A is 12. And side B is 15. So if I draw my triangle like that, that would be our possible scenario. So let's actually solve that. Let's figure out what angle B is. And actually we'll do B, C, and side C. We'll solve the triangle completely. Okay, so if we let's start with angle B first. So we'd have sine B over 15 would equal sine 45 over 12. So if we cross multiply those on our calculator, we get sine 45 times 15 divided by 12 gives us 0.88. But remember, we want angle B, so we got to go second sine, and that'll give us 62 degrees. So if B is 62 degrees, we can use the 180 rule, so that would be 107. So that means this one up here would have to be 73 degrees to add up to 180. So then we can figure out side C, so side little c. So let's do sine law again. So we'd have C over sine 73 equals 12 over sine 45. And if we cross multiply those this time, so 12 times sine 73 divided by sine 45 gives us a little c of 16.2. And that's it. We've solved the triangle. Everything's good to go. And you might ask, well, what's the problem? Well, there isn't a problem if that's the way the triangle was actually supposed to be drawn. So what happens is we could have actually drawn this exact same triangle with our 15 and 45 degrees the same. But we could have actually drawn the 12 coming back down instead of outwards. So you can see we'd have our B and C would look like that. So if we try to solve for angle B this time, we'd have sine B over 15 and sine 45 over 12, the exact same calculation. But if we put this on our calculator, it'll still give us 62 degrees. Is that 62 degrees? No. This angle looks a lot bigger than 62. So we run into a bit of a problem. So we'll come back to this in a second. Let's kind of go through the rest of the notes. So a couple of things to remember is the ambiguous case only happens when you have an angle less than 90 degrees. And we're going to come to the rest of this again later. So the trick is when you're calculating the ambiguous case, your calculator is only always going to give you the smaller of the two angles. So for this, the way I've got this triangle drawn, when we solve for angle B, it's going to give us this small angle over here, not the bigger angle that we want. So the trick is we need to subtract it from 180. So let's go back to our first question. So if that's 62, you can see that was our 62 over here. So what ends up happening is we get a triangle. If this is 62 and these two sides are the same, we have an isosceles triangle, which would make that bottom angle 62 as well. So the one that we're actually looking for is 180 minus 62. So we have to do the supplementary angle calculation, which your calculator won't do. So we actually get 118 for angle B. Therefore, our C now would be 180 minus 118 minus 45. So we actually get a way smaller angle for C. So that's 17 degrees. And now to find side C, we'd have C over sine 17 instead of 73. So we will actually get the correct calculation in this case too. So the only thing that you got to be careful of when you're doing these is to make sure you do the 180 minus that angle when you have the ambiguous case. Your calculator won't give you the correct answer, so you have to remember to do this minus the 180 thing all on your own. So in this case, when we divide this one out, we get about 5 for C. So 4.96, which rounds off to 5. So you can see the distance is a lot shorter, but our angles are a lot different as well. So the trick then is, when does the ambiguous case happen? So first thing, we see that it only occurs with small angles. So if that starting angle was less than 90, we could have our triangle going that way, or we could have it going that way. If we had a large angle to start with, an obtuse angle, our other side is either going to be too short that it wouldn't make a triangle, or if it's long enough, we wouldn't get any other triangle, because if we spun it the other way, it's not going to make a triangle either. So they only occur with acute angles. You can see in this case, that one didn't work, or that one didn't work. We only get one triangle at the most. The other scenario is what happens if that side is too short. So let me open up a new page here again. So you can see with this one, okay, so you can see with this one that we get our ambiguous case would occur. But what would happen if this, let's look at the side B, if this side B was much too short? So if this side B was only, say, that long, we could swing it any location. It's not going to even touch to make a triangle. So we run into a problem that way. So what ends up happening is we sort of have a critical number of what that vertical height would be. So we could actually calculate the vertical height for this case. We'd have sine of 10 degrees equals height over 15. So if we cross multiply those, so sine 10 times 15 gives us a height of 2.6. So what that means is anything smaller than 2.6 is going to be too short. We're not going to get any triangle. Anything that's exactly 2.6, we're going to get just one triangle. So you can see here, if A is too small, we don't get a triangle, nothing exists. If we get exactly that height, we have one right angle triangle. So that's our regular 90-degree angle triangle scenario. If A is bigger than 2.6, that's when we're going to get our ambiguous case. So it has to be bigger than 2.6, or sorry, bigger than the height of 2.6, but it's got to be less than our other side, because if it was bigger than 15, we'd end up getting just one big triangle, and that one wouldn't work either. So the only time we have an ambiguous case is when that height distance on our number is bigger than that height but less than the other side. That's the only case that we get an ambiguous case. So if we go back to this one again, you can see we do have the ambiguous case, because it's 4 is bigger than the 2.6 we calculated, but it's less than the 15. So we could swing this side 4 over to here, and we'd get our two possible triangles. So like I said before, the only thing, if you get the triangle picture given to you, then you already know it's good. We have the ambiguous case scenario. So the only thing we got to be careful of when we solve it is to make sure you do the right calculation. So in this case, we'd have B over sine 10, and we'd have A, which is 15, over sine A. Oops.
To the office, please.
Our B is 4. I messed up on that. So we'd have 4 over sine 10 equals 15 over sine A. So when we do our calculation on that one, 15 times sine 10, divide by 4, second sign your answer, we get an A of 40 degrees. 41 if we round it off, or 40.6. So once again, if we go back to this question, that 40.6 isn't the angle we're looking for. That's actually the smaller one beside it. So we actually have to go 180 minus the 40.6, and that gives us 139. So in this case, angle A is 139, and then once we have angle A, we can solve for angle B, B is 10, so that'd be 149. So C would be 31 degrees, and then we can use sine law again to get side C. And that's it.